Welcome to another session of Everyday Mathematics. Here at Everyday Mathematics, our slogan is that we do enjoy solving the harder problems, but also we do see and appreciate the beauty in the simpler problems. So today, we have we're now moving away from the trigonometrical functions, and the first problem that came to mind was from the MIT 2022 Integration B regular season. We're looking at the first problem on floor functions. So we'd call this part one of the regular season floor function series. And that's problem number one, the integral from x equals to 0 to x equals to 100 of the ceiling function of square root of x, which is very interesting. I guess we could have titled this session Floor and Ceiling Functions, but all the same, we'll be looking at the ceiling function related problem today. Before I go ahead into the solution side of things, I'd like to thank our subscribers. Thank you so much for walking along this journey with us. We do appreciate your support. For our first-time visitors, we encourage you to subscribe to our channel. What we do here is pretty much, solve the harder problems. We also have simple problems from time to time, but we do enjoy mathematics as a baseline. And then if you're here for the second, third, or fourth time, but still can't figure out as to what use this channel would be to you, please hang around. We believe the numbers that we solve could be entertaining to you. So quickly into the solution. The first thing that I would like to look at is we have an interval from 0 to 100. So x lies between 0 and 100. And that means that the square root of x is between 0 and 10, right? Now, when the square root of x is between k and k plus 1, where k is the integer, between the interval that we're looking at here, it means that x is between k squared and k plus 1 squared. And so the ceiling function of the square root of x is equals to k plus 1. This is the definition of the floor of the ceiling function, where ceiling function is equal to the integer above the real number under consideration. Therefore, now when we integrate the ceiling function of the square root of x from 0 to 100, that means that we have to look at k lying between 0 and 10. So we have strips between 0 and 10. And in each strip, the x value straddles between k squared and k plus 1. So k squared and k plus 1. That's the range within which x lies. And then within that range, the square root of x ceiling function is k plus 1. So we can now go ahead and pull this k plus 1 out of the integration sign because it's a constant. And now we are basically integrating 1 from k squared to k plus 1 squared. So the integration now becomes, obviously, integration of 1 is x, k squared to k plus 1 squared. Now, when you substitute in the limit, k squared minus plus 1, k plus 1 squared minus k squared is 2k plus 1. And so we have k plus 1 times 2k plus 1 under the summation sign. And that means that now we have the summation from k is equals to 0 to k is equals to 9 of 2k squared plus 3k plus 1. So which is as shown there. Now we know some basic series formulas here. The summation of k squared from k is equals to 0 to n is n times n plus 1 times 2n plus 1 over 6. The summation of k from k is equals to 0 to n is equals to n times n plus 1 over 2. And so since our n is 9, for 2k squared, we have 2 times 9, which is n plus 1 is 10, 2n plus 1 is 19 over 6. And then 3k would be 3 times, we have n, which is 9, n plus 1 is 10 over, made a mistake here, so we need to put here 2, okay, plus, so they are 10 items. So when we have 1, 1, 1, 1, 1, from 0 to 9, we have 10, so plus 10. So we have now 570 corresponding to this, plus 135 plus 10, which is 715. And that is the final answer for this seemingly intricate problem. Thank you for hanging out with us. It was an absolute pleasure solving this problem. Please subscribe to our channel. Until next time, bye-bye.